Chapter 2, Key Issue 2, is about why the global population is increasing. And so we want to go over some of the measures we use to look at population change. These can be measured in a country level, or they can be measured on a global scale. So the three main measures for measuring population growth are crude birth rate, so CBR. CBR is the number of live births per every 1,000 people alive in society. So a high crude birth rate means people are having a high number of children, and that those babies are being born alive. Crude death rate is the total number of deaths in a year for every 1,000 people alive in society today. And so a high crude death rate could indicate lack of access to healthcare, so people are dying quickly because they don't have access to medical care. It could indicate, an outbreak in an area, a disease outbreak. It could also indicate a population that's getting older. So if you have a population of mostly elderly people, you will have a higher crude death rate than a crude birth rate. In fact, in the United States, we had more people die last year than were born in our country because we have a population of people live to old age in our country, and so we don't have as many children as a developing country. And so we have more elderly people dying, essentially, than we have being born. Countries like Japan and Denmark have this problem as well, but far more extreme. The natural increase rate, or the NIR, shows you it's the percentage by which a population grows in a year. And the calculation in your book says crude birth rate minus crude death rate will equal NIR, but you need to divide the NIR by 10, because this is per 1,000. And if you need it in a percentage, you need it to be per 100. So 1,000 divided by 10 will give you 100. And we'll do some practice problems in class. So if you're not super mathy, we'll work on it together. But crude birth rate minus crude death rate is equal to NIR, and then you divide that by 10 to get the percentage. This graph here shows you human population growth over time. And you can see that through most of history, human population growth was growing at a slow and steady path. And then when you hit right about here, right about the time of the Industrial Revolution, our population started to skyrocket. And when you have a population that grows very quickly, we call that exponential growth. Think about how you can increase something faster if you're adding exponents to it than if you're just, adding the numbers together. So 3 to the third power is 9. That's growing exponentially. That's a much larger number than 3 plus 3, which would be 6. So this here is showing exponential growth and not arithmetic growth. So the population is growing quickly, and this usually indicates that whatever organism is growing at that rate, in this case humans, they have a lot of resources. There's not many limits to their growth. What happened to make our population skyrocket? We had access to things like engines and machines, so we could start to industrialize our farming. We could grow more food per acre, so we had more access to food. We had advances in technology, like advances in medical care. Think about things like anesthesia, antibiotics, vaccinations, even doctors washing their hands before they perform surgeries. Sewage systems, indoor plumbing, all of these things have extended our life. And many countries, screens and air conditioning have depleted mosquito-borne illnesses like malaria because you're not outside as much. And if you are sick, you're usually in an air-conditioned hospital. Things like having clean drinking water gets rid of diseases like cholera, which is a diarrheal disease. So the population starts to skyrocket. And right now, at least from 1950 to 2000, the world's population doubled in 40 years. And if you go back until about 8,000 BC, it was taking 59,000 years for the world's population to double. So once the population got about here, it started to double every 160 years, then every 130, then 85 years, and then every 40 years. So right now we are at, I believe, about 7.4 billion. And I worked in that exact classroom where you guys sit every day when the world's population hit 7 billion in 2012. So natural increase rate, again, is what we were looking at. So a high rate of increase rate affects the doubling time, which causes exponential growth, and we kind of just talked about this. Today, most of the natural increase rate is clustered in developing countries. So if you look at this map here, you can see where the natural increase rate is about 2% a year. It's probably going to be in Central Africa, Sub-Saharan Africa, a few countries in the Middle East or West Asia, Southwest Asia, and then some areas here in South Asia, and then a little bit down here. You also might notice that most of the places in the world that have a high natural increase rate weren't in those population clusters and weren't listed among the most populous countries. And there are some exceptions. So Pakistan, which is one of the world's most populous countries, has a high increase rate. It's a country that's still rapidly growing. But places like China have a growth rate comparable to that of the US, so it's slowing down. It's probably not growing very fast at all. Its growth rate is under 1% a year. India has gone from between 1 to 2, so it's slowing down. Mexico's growth rate has slowed down. Brazil has a natural increase rate like that of the US and China. Europe either has a slow growth rate or a shrinking growth rate. So the most populous places in the world, Europe, Southeast Asia, East Asia, and South Asia, most of those areas either have a stable population growth or it's not really growing at all anymore, except for this area here in South Asia and a little bit there in Southeast Asia. So most of the natural increase rate that's really high is going to be in Central Africa and Sub-Saharan Africa, although there are other exceptions like Papua New Guinea and some areas in Central America. When we measure total fertility rate, we're looking at the average number of children a woman will have through her childbearing years. And if you're looking at total fertility rate, you're looking at an estimation for an entire country or an entire state or an entire region or for the entire world. So you wouldn't look at like the total fertility rate for one person. You'd have to look at a population. The total fertility rate for the world is 2.5. And so you might have heard people say, the average number of children a woman in the U.S. will have is 2.5. Clearly, women aren't having half of a child. But when you do the math, it comes out to be 2.5. So some women are having 2 kids, some women are having 3, some have 1, some have 4, but it averages out to be about 2.5. In Sub-Saharan Africa, where the population, the natural increase rate is so high, the total fertility rate is 5 or higher, depending on what country you're in. And in areas in European countries, it's 2 or less. And so if you look back at this map, you can kind of see that areas that are the lightest shade are going to have less than 2. Countries that are like this peachy color are probably going to have a total fertility rate of about 2. These light orange countries, a little over 2. And then here, these dark orange countries, you're looking at 3, 4, 5, sometimes 6 or 7 children on average per woman. And if you looked at these two maps and you laid them over each other, high total fertility rate will lead to a high natural increase rate because you're having a high number of children. Of course, you need to have these children born alive in order for that natural increase rate to stay high. And so we also look at infant mortality rate. Infant mortality rate tells us the death rates in a society. It also tells us what we can expect with population growth. So this is looking at the number of deaths of infant under a year of age compared to the total live births. And it's usually expressed per 1,000. Infant mortality rate is a 5 in developed countries. So on average in a developed country, so like most countries in Europe, Canada, US, about 5 infants per every 1,000 die before they reach the age of 1. So that shows that most of these infants have access to medical care. So they're going to go to doctors, the moms have prenatal care, they have vaccinations. In some countries in Sub-Saharan Africa, the infant mortality rate is 80. So 80 infants per 1,000 die in the first year of life. And Afghanistan right now, which has the highest infant mortality rate in the world, at least according to the fact book on the CIA's website, has about 129 infants die per every 1,000 born. And then the countries that follow that would be Mali and Somalia. So those are the 3 countries in the world with the highest infant mortality rates. In areas with high infant mortality rates, people tend to have more children. So a culture in a region with a high infant mortality rate, people have more children because they kind of know that all of their children won't survive till adulthood. So they have more babies. Also, high infant mortality rate is correlated to lack of access to medical care. And if you don't have medical care, you don't have reproductive health strategies necessarily or access to them, so you'll have more children. If you look at the crude birth rate per every 1,000, you see areas with a high natural increase rate, again, have a pretty high crude birth rate. Pakistan is kind of leveling out. Mexico is starting to level out, but you see that same general trend in this area. So why is global population increasing? Let's look at some spatial patterns. So in general, in a developed country, you're going to have a lower natural increase rate, so the population is growing at a slower percentage. You're going to have a lower crude birth rate. People have less children. You're going to have a lower total fertility rate because people are having less children. And infant mortality rate is going to be low as well. So the children that they do have, the infants that they do have, survive through their first year. In developing countries, you're going to see higher rates of a natural increase. You're going to see a higher crude birth rate, so that makes sense. If you have a high natural increase rate, you're going to have a high number of infants being born. The total fertility for the country is also high, which again makes sense. And the infant mortality rate is high, which leads to people having more children. And it ties into the lack of access to healthcare. Here you can see the crude death rate per 1,000 people. So the crude death rate is going to show you how many people die per 1,000. So the crude death rate in the U.S. is lower. And again, in areas with less access to healthcare, you'll have a higher crude death rate. You also might have a higher crude death rate in a country with an aging population. So if you have more people that are elderly in your country, you'll have a higher crude death rate. But in general, it correlates to lack of access to clean water, sewer systems, and medical care. When we look at population that's increasing, we're going to look at something called a population pyramid. And population pyramids show you how a country's population is changing over time. So on the x-axis, you're going to have one side of the graph be female and the other side have male. And then on the y-axis, you're going to have the age cohorts. Usually they're broken up into 5-year intervals. And you'll have the youngest at the bottom and the oldest at the top. So when you look at the population pyramid for the U.S. in general, you see them here, they are males, here are females, and it's usually labeled for you here. This is the percentage of individuals that are between the ages of 0 and 4 in the U.S. So you can see that we have less individuals under the age of 10 than we do that are older. So that shows you that the growth rate of the U.S. is slowing down. When you see here, this told you we had more children being born about 15 to 20 years ago. We had a little dip in here about 30 years ago. And then you can see the baby boom, 50 years ago. When you get older, the pyramid starts to get smaller because people start to die, when they get elderly. And so you'll never have more people up here. You wouldn't usually have more people up here. And the very tip of your pyramid will get smaller. And you can also see some other trends, like there were more females that lived to old age than males because females tend to live a little bit longer. We are going to go over population pyramids and what they mean in class because it can be kind of confusing. But you can see a little bit about these different areas. And so if I look at Lawrence, Kansas, I see there's a lot of people in their 20s. So this to me looks like probably an area in Kansas that would have maybe a college town or some kind of prep school because there's so many young people. So these people that are college age live there. And then the rest of it looks pretty similar. So this spike in ages 20 to 24 makes me think that there must be a college in Lawrence, Kansas. Naples, Florida is a retirement area, right? How do I know that? Look at the number of elderly people in Naples, Florida compared to young people. So this pyramid is really rare where you see that many more older people than young people. And we know that, you live in South Florida, people come down here to retire. And Laredo, Texas, we can see that this population is growing pretty fast. There's a lot of younger couples, they're having a lot of children, so this is a big family area. And we'll go over these patterns a bit more in class. The last thing to look at is dependency ratio. Dependency ratio is the number of people who are too old or too young to work compared to the number of people in their productive years. So people under the age of 15 are considered dependents and over 65. People before they're able to work and people who are usually retired. A large dependency ratio implies a financial burden on the working class. And so we have an 85% dependency ratio